Hello my dear friends, I am Professor Ryan Khan and this is the part 3 of unit number 4, steels and cast irons. In previous videos we have seen the classification of steels and we have seen the designation system of steel on the basis of the Indian standard designation system, and in that Indian standard designation system we have seen how the part 1 and part 2 of the designation system works, how the numbers and the symbols are used. In today's video we are going to continue with the steels part of this unit number 4, and in this part we will be continuing with the designation system of steel. And in this today's video we will discuss the designation system of steel on the basis of AISI or SAE designation system. Okay, so let us begin. So there are two types of designation system that we have to study. First one we have already covered, that is Indian Standard Designation System, and which is based on Indian Standards Institute, and another one is AISI or SAE type of designation system, which we are going to continue in today's video. So AISI or SAE designation system is basically a designation system which is used universally all over the world most of the time. AISI stands for American Iron and Steel Institute, which designates, which gives naming or nomenclature to the iron and its related alloys like steel. And SAE stands for Society of Automotive Engineers, which is a society, or which is an organization based in London, which have various branches or various offices all over the country, all over the world. Okay, so this AISI or SAE designation system classifies the steel or alloys on the basis of their chemistry, that is on the basis of their chemical composition. So they basically provide standardization of steel used in automotive industry. So these nomenclatures are more popular in the automobile or automotive industries. So whenever a part is manufactured in any automotive industry, for any kind of part, the steel which is used is most of the time designated by AISI system. So this AISI system has around 4 or 5 digits, 4 to 5 digit number. It is basically a number which is having 4 to 5 digits, and you can see here it is written like AISI XX, like that means there will be some numbers, there might be 4 or 5 digit number, and before that it might be written as AISI. Okay, so let us see what is the system. So we have around 5 numbers, 4 to 5 numbers in the designation system of AISI. The first number, it represents the type of steel. So the first digit from left to right. So I am going from left to right now. Okay. So if the number is 1010, it means the first digit is 1 here. So first number is the type of steel, and the type of steels are as follows. There are 9 type of steels which are standardized by AISI or Society of Automotive Engineers. Like first, if the digit number 1 is 1, then it means it is a carbon steel, that is it is a plain carbon steel. If the number is 2, then it means it is a nickel steel, which is having nickel as its alloying element. Then if it is 3, it means it is a nickel chromium steel, and ICR are the main alloying elements in it. Then if it is 4, first digit, if it is 4, it is molybdenum steel. If it is 5, it is chromium steel, which is having chromium as its main component, as its main alloying element. apart from carbon. Then sixth is chromium vanadium steel, seventh one is tungsten steel, eighth one is nickel chromium molybdenum steel, and ninth one is silicon manganese steel, SiMn steel. So if the number is 1, 2, 3, 4, 5, 6, 7, it will be having a respective meaning. So we'll write the respective name of the steel there. Okay. So this is about the number 1 from left to right. The number 2, for simple alloys, second number designates the approximate percentage of predominant alloying agent. So when I am saying predominant alloying agent, for example, if my first number is 3 or if my first number is 4, so here that steel is MO steel, that is molybdenum steel. Okay, so that means my predominant element here is molybdenum. Okay, so therefore the second digit which is present after this number will give the approximate percentage of the predominant alloying element. For example, if I am having digit 4 and if after that it is 2, that means there will be 2% of molybdenum in that molybdenum steel. It indicates the predominant percentage of predominant alloying agent. And for others, like for other alloys, it indicates modification of the alloy in that alloy group. It indicates modification of the alloy in that alloy group. So this was about first and second number. Then the last 2 or 3 digits, or 3 numbers divided by 100 gives us the average amount of carbon. For example, if my number is 4220, that means this last 2 number divided by 100 will give us the percentage of carbon, that is the average percentage of carbon. So it will be 0.2% carbon. So this is a molybdenum steel with 2% molybdenum and 0.2% carbon. Okay, so this is the way of designating steel by AISI or SAE. Some of the examples are written here, let us understand them. So here it is 1, 0, so this 1, so there is always 0 in it because here it is the plain carbon steel, so most of the time it is 0. So 1, 0, that is 1 stands for plain carbon steel, 0 means there is no such predominant element in it, so therefore 0, and 40 it represents 0.4% carbon. So it will be written as AISI 1040 like this. Then again 2440, so 2 stands for nickel steel. Then there is 4, second digit is 4, that means percentage of nickel is 4%. Okay, and at last 2 numbers are there, that is 40. So this 40 divided by 100 gives us 0.4% carbon. There is 9260, then 9 means silicon manganese steel, in which the percentage of silicon is 2%. Okay, and 60.6% is the percentage of carbon, average percentage of carbon. Again there is one more number, this is 4, so it stands for molybdenum steel. If it is 1, then it gives us 1% of molybdenum, and 40, that is 0.4% of carbon. So this is the way of designating AISI or SAE steel, or you can say this is the method of designating steel by the Society of Automotive Engineers or by the American Iron Steel Institute. Okay, so this again there are some special cases in which there is possibility that in addition to these numerals, AI specification may have some letter prefix that is later written before the numbers, so to indicate manufacturing process like this. So if my steel is 2240, okay, so there will be some alphabet written before to this prefix to it, like B2240. So that means its method of manufacturing is acid BCmer. Acid BCmer. Okay, so it is manufactured from acid BCmer process. So similarly, if it is having A letter before it, if the number is having A letter before it, it means it is a basic open earth alloy steel. B means acid beamer carbon steel. C means basic open earth carbon steel. Then D means acid open earth carbon steel, and E means electric furnace steel. And if there is no alphabet before any number, so that means the absence of this prefix means that it is an open earth steel. So it is made in open earth. Okay, so open earth steel. Certain this is a table which gives us certain examples, certain you can say designations, some more designations of steel on the basis of AISI. So carbon steels, so 10XX. So this is a plain carbon steel. Its manganese percentage is 1% max. 11XX. So this XX will give us the percentage of carbon, but this 11 means resulfurized free machining steel. 12 means resulfurized, rephosphorized free machining steel. So these are free cutting steels. 11, 12 are free cutting steels which have phosphorus or sulfur in more amount, which makes them free cutting. Then again this 15 means plain carbon steel. Its manganese percentage is from 1 to 1.65. Then there is manganese steel, specifically manganese steel, which is having more amount of manganese, around 1.75%. So this is given by 13. Then there is nickel steel. So nickel steel 2, 3. If it is having maximum amount of nickel up to 3.5%, if it is up to 5%, it is written as 2,5. Okay. Similarly, nickel chromium steel 3,1, where nickel is 1.2% and chromium is around 0.65 to 0.8%. So overall average of both the predominant elements like nickel chromium is 1%. Average percent. If you consider this 1.25, so this nickel 1.25 will be rounded down to 1, and this chromium 0.65, 0.8, it goes around 1.4, so it will also be rounded down to 1. So therefore it is written as 3,1. Okay, again 3,2, so 1.75 it will be rounded up, 1.75 will be rounded up to 2, and similarly this chromium will also be rounded up to 2. So therefore it will be written as 3,2. Again 3,3, 3,4, same meaning. Molybdenum steel 4,0. So 0 means it is having very less amount of molybdenum, around 0.2%. 4,4 means it is having molybdenum around 0.4%. Okay. Then 4,1 chromium molybdenum steel. Then 4,3 nickel chromium molybdenum steel. 4,7 nickel chromium molybdenum steel. 4,6 nickel molybdenum steels. 4,6, 4,8 is used for them. Okay, where nickel and molybdenum is present. Okay, then chromium steel starts from 5. So 50, 51, 52 are the numbers of chromium steels generally. Chromium vanadium is for 6. So 61. Again tungsten chromium steel 72. So tungsten is around 1.75%. That is, if rounded up, it will be 2%. Therefore 2. Okay. Again 81. That is your nickel chromium molybdenum steel. And ICR ammo steel. So it is having numbers from 81, 86, 87, 88 around like this. Silicon manganese starting from 9. Nickel chromium molybdenum steel starting from 93, 94, 97, 98. So these are the some of the examples of steels which are designated from AISI. So in next video we will study about the significance and applications of plain carbon steel, and then we'll move towards the